Hi, I'm Valerie Bodell. Welcome to Order and Chaos. This is the first in a series of 3 related courses in the Chaos Trilogy. This is a 5-week, 1-credit course. As promised, you don't have to buy any books for this course, and you will not be solving any math or physics problems. This class is about understanding ideas. Now, there'll probably be some unfamiliar words or words used in unfamiliar ways. Don't let these scare you. Open up a dictionary in your browser as you read. Remember that educated people look up the meanings of words all their lives, and feel free to collaborate on definitions in D2L. The syllabus is in D2L, and you can read it there in its entirety, but there's a couple things I wanted to point out in particular. Discussions are a large part of your grade. To get full points on discussions, you need to participate in the conversation, not just reiterate what your classmates have written. Consider composing your post and getting things down in your own words before reading your classmates' posts. I'll be looking for posts of a paragraph or 2 that present your ideas and back them up with examples from the reading. I'm not worried that you have perfect grammar or spelling. I'm looking for you to understand the readings, that you can relate them to the larger world. Replying with "I agree" will not be enough. I'll be looking for replies that comment on what your classmates are discussing and take it a step further or bring up something new. My contact information is in my D2L profile and on the syllabus, but wanted to make sure you know that the best way to contact me is by email. I generally respond to emails within 24 hours, but I check my email less often on the weekends. Please do not wait until late Sunday to read your assignment and realize that you don't know what you're supposed to do. Please read the assignments early in the week and email me with any questions while I have time to help you. If you'd like to talk on the phone, my number is 423-439-7182, and you can leave a message at that number if I don't happen to be in. If you'd like to meet in person, just give me a call or send me an email, and we'll arrange a time to meet. Your final assignment is a formal paper, about 5 pages, about 1,000 words. Your paper should have an introduction with a thesis statement, a body, a conclusion, and works cited. Your paper should demonstrate your understanding of dynamical chaotic systems by exploring any aspect that interests you. I encourage you to submit a draft early enough for me to make comments and early enough for you to make corrections. Now let's address the question of why anyone would care about chaos and how it might help you to know if your system displays chaotic behavior. The world is full of complex systems with seemingly random behavior. So let's start by distinguishing between random and chaotic. If your system displays chaotic behavior, then 2 processes that start from identical initial conditions always reach the same end. The process follows regular physical laws. The current state is a function of the previous state, and the outcome is predetermined. Chaotic systems are deterministic. But chaotic systems are very sensitive to initial conditions. So 2 processes that start from infinitesimally different initial conditions reach wildly different ends. This sensitivity to initial conditions often makes chaotic systems appear random. To distinguish between the random and chaotic, you would plot points through time, a lot of points. And your plot would show that the data points either cluster into a shape, which we'll discuss in week 3, or they show a random distribution. If your system displays random behavior, then 2 processes that start from identical initial conditions may reach different ends, and usually do. The current state is not a function of the previous state, and the outcome does not depend on initial conditions. Random systems are non-deterministic. Software engineer Jason Yin has a good discussion of the difference between random and chaotic, and I've included a link on week 1 in D2L if anyone is interested. Once we can identify a system as one or the other, as chaotic or random, we can tailor our reactions to a situation. Once we understand that weather patterns display chaotic behavior, then we know that we cannot predict the weather very far into the future, because remember that the sensitivity to initial conditions and that our weather system is so complex. So remembering that the sensitivity to initial conditions means that if two processes start from infinitesimally different initial conditions, they go to wildly different ends. Because our weather system is so complex, we can never identify all of the influences, all of the variables, and we can never identify them in enough detail to get our prediction the same as actual weather, because our forecast and the reality are starting from different initial conditions. They very quickly diverge towards those wildly different ends. When we study chaotic systems, we will learn to expect variation, but that variation has limits. So though the local weather is unpredictable, it remains within a certain range, and that range shifts predictably and reliably with the seasons. Because chaotic systems are deterministic, we know that in some situations we can work with variables and try to search for relationships that lead to stability or appropriate oscillation. So we can tailor our reactions to situations once we know what kind of systems we are dealing with. Though chaos has negative connotations, it's not always a bad thing. Granted, if a bacterial infection is surging out of control in a body or a population, that's probably going to be considered a bad thing. But understand that reducing chaos may not always be the goal. There's a value to chaotic processes in the heart and brain. And chaos in the behavior and characteristics of a natural population preserves adaptability to a changing natural environment. Chaos in the behavior and characteristics of a social group preserves adaptability of that group to a constructed environment of big business, for example. Understanding chaos furthers our endeavors in fields as diverse as industrial engineering technology, disaster management, cryptography, and population dynamics. As you learn more about chaos, we will look at images of chaos, and you may ask, why does seeing a picture of chaos help? Though chaotic behavior can proceed from simple mathematical processes, the behavior itself can be very complex with many variables. And instead of dealing with unwieldy formulas to describe that behavior, chaologists use graphic representations. And I hope when you look at the images, as I can see the order, you will be able to see it. You will be able to see stability evolve into chaos and back again with distinct boundaries between the states. Well, I think that's enough to give you an idea about chaos, and I look forward to working with you in the next weeks.